Now let's talk about what kinds of tests there are, what kinds of logical tests there are. There are two main tests that I want, types of tests that I want you to know of. Um, I mention these because if you go into industry for an internship or then for a full-time job, you'll hear people talk about unit tests and integration tests. So unit tests are tests that verify that individual units of our program, so individual small parts, oftentimes functions are natural units to test, that they're working as expected. So oftentimes you break down some more complicated program into functions naturally when you're coding, and unit tests verify that small parts of our program are working. Whereas integration tests are tests that verify that the whole program performs as expected. An example of both of these for YouTube, for example, would be maybe a unit test would check that pressing the like add a comment button or the reply button on a comment opens a reply box below it, because there's probably one function that handles that particular thing. When you click this button, open a new comment below. Whereas an integration test for YouTube might be some automated test that checks that when you go to youtube.com and you click on the first picture that you see, which is a thumbnail, that a video starts playing. So there's all sorts of code that has to work correctly for that. There's functions that I'm sure handle the actual request to get the website when you type in youtube.com and return the whole page. There's functions that are responsible for building the image that's shown, the thumbnail. There's probably a function that's responsible for loading the page that actually plays the video and then for actually streaming the video to you. And so the integration test verifies that the whole program end to end works. So why do we need these unit tests? By checking that each individual part works, we can be more confident and less confused when we're testing the overall part. So having tests for each individual function, each small piece, lets us catch our error with more granularity. So we know that, okay, it's not just YouTube that's broken, it's this particular part of YouTube is broken, and if we fix it, then YouTube will work. I'll give some examples here from our recent lab. In lab 7, book analysis is a pretty big task, and so we broke it down for you into smaller pieces. And so if we were to write unit tests, we would write some tests for each of the functions that we had. So for read file, for get words from string, get words from line list, count frequency, and find most common word. As you think about how to write these, you can think back to the stuff we talked about earlier in this lecture, which was how do we break down the possible input into different cases? And so there's this common case maybe for get words from string, the common case of just a string with a couple words separated by spaces. Whether there's 3 words separated by spaces or 10, if it works for 3, it'll probably work for 10. But then there's less common cases, like what if it's all one big word? Or what if it's one big string with no spaces? Or what if it's one big string that it's a string that has multiple words separated by spaces, but there's some punctuation? Or what about a case where it's an empty string? How does it handle uppercase or lowercase? How does it maybe handle numbers in a word? And you would think through that for each of your particular functions. So what are the different kinds of inputs you could give it until you have full test coverage, meaning you think you've covered all the possible classes of input, all the possible types of input. And so I talked through that for get words from string. What does that look like for maybe count frequency? So given a word list, maybe we'd want to try a list with all unique words. And so we would expect to get back a dictionary with all of the words as keys and a value of 1 for each of the words. Maybe we'd want to try a case where our list has a bunch of the same word, and we want to make sure that that case would be handled, where you count up the same word a bunch of times. We'd want to try to test something in between, where there's some words that appear multiple times, other words that appear only once. Of course, a common good thing to test is that an empty list is handled correctly and you get back an empty dictionary. And so those are all the types of inputs I could think of that we want to have a separate unit test for. Now about the integration tests. This is how we make sure that our entire program works as expected. You might ask, well, Alex, if I've written good unit tests, then shouldn't I catch any kind of error that comes up? For the most part, yes, but in reality, you end up not being able to catch your errors because your functions do individual units of work, but somewhere you have to call your functions and put all the pieces together. And the integration test is the way, what you should think about it as is how you test that all of the different functions of your program come together and work in unison. So you'd want to make sure that if you have one function that returns a list and then you call a different function with the output of the first function that's expecting a dictionary instead, when you put those together, your code will break and an integration test will catch that. Whereas your unit test for each individual function might work because the individual functions work as expected if they're given the right thing. But if you try to hook multiple functions together and give one function the input that's the output from a different function, they don't line up, an integration test will catch that kind of error. And so for our book analysis, it would be just calling that end-to-end function, the very last one that called all the other functions. Try giving in the text of Shakespeare, or try giving in the text of some other author. And in fact, you'll notice that's exactly what we did for your code. So we had a bunch of unit tests for each of your functions, and then we had this kind of integration test, which was actually just calling your last function that put everything together. That just, here's an input, and your whole program is a black box. And you check that the output is correct. Now we talk about all of these unit tests, integration tests. All of this is automated, and so we don't have to manually call your function to test it. If you write test cases in a separate file, you could just run that file, and after each change, you could see how how well your function is written, if it does what you expect it to do. In fact, that's what you've been doing all along this semester. It's as if you had a file with all of the test cases in it, which is what Mimir has. And when you submit your code, it runs all the test cases. And as you pass more and more test cases, that's how you know how well you're doing. And so this is actually something called test-driven development. Very common in industry, where first you write your tests, because your tests are they define the expected behavior of your code. So you could actually write your tests before writing any code because you know what your code should return. And then you write your code and keep working on it until it passes all of your test cases. And if you've written a comprehensive set of tests that have full test coverage, you should know by the end of it that if all your test cases pass, that you have a program that does what you expect it to do. Now I'll jump back here. I'll talk a little bit about my experience with testing at Google. These tests are super important because many times you'll have multiple people working on a code base, and eventually someone leaves the team or quits or just changes teams for whatever reason. Their code still exists and it's still running, and someone has to maintain it, and someone's going to make changes to it, and you want to make sure that the changes that you make to a code base don't break things that already exist. So when you add new functionality, like if you want to make some changes to how comments work on YouTube, you want to make sure that the existing features for comments that you can reply don't break by that. And so by having good tests written out, you can make sure that after you make your changes, all the existing tests still pass, and so your code still functions as expected. So to summarize testing, it's all about trying different inputs and checking whether the output is correct. And unit tests let us verify individual functions perform as expected, and they help us catch bugs at a more granular level, so we know that something's wrong with this particular function. The integration test, type of a test, verifies that the whole program works end-to-end, and verifies that the individual units are hooked up together. And if you're curious, in industry, every time we submit a change to the code base, where you write a change and you save the file and you submit it, all of the tests get run to make sure that nothing broke. Like that's the way that we keep everything running. That's how Google is up all the time and how YouTube is up all the time, because before saving any of your code and kind of pushing it, which you'll learn about in later semesters, we run all of the test cases to make sure that none of the existing functionality broke, which is why we need such good test coverage. Okay, and on that, we'll be done for today, and I'll see you in class. Bye.